Hi everyone, today we're going to be looking at chapter 3.4, the variable scope in the app development with Swift textbook from Apple. Okay, so let's go ahead and get started here. Using a comment or print statement, describe why the code below will generate a compiler error if you uncomment line 10 rather. So this is line 10. Well, let's have a look at it. This will bring an error because we're actually creating the constant foo inside the for loop, so it has a local scope to that for loop. So we're trying to use the variable foo outside the for loop because the for loop ends here. So I'm gonna write that the above line 10 will not work if we uncomment it because we are attempting to use a constant foo outside its scope. In this case, the for loop scope. Cool. Using a comment or print statement, describe why both print statements below compile when similar looking code did not compile above. In what scope is X defined, and in what scope is it modified? In contrast, in what scope is foo defined and used? Let's have a look here. These both actually print and work. Obviously, if we go ahead and run this fully works. And the reason it works, let's go ahead and write a comment. The reason it works is because we've created X up here. So since we created this variable X up here, we gave it a global scope. So we're using it locally here, but it's available for us to be used locally here because it has a global scope. It's outside the for loop, and we could use it in here as well because, like I said, it has a global scope, so it's available to all local functions. So the reason these two lines work when using X is because X is declared globally. Cool. Foo was declared locally. Perfect. All right. In the body of the function greeting below, use variable shadowing when unwrapping greeting. If greeting is successfully unwrapped, print a statement that uses the given greeting to greet the given name, i.e. if greeting successfully unwraps, to have the value hi there and name is Sarah, print hi there Sarah. Otherwise, use hello to print a statement greeting the given name. Call the function twice, once passing in a value of greeting and once passing in nil. So we have to use variable shadowing here. So how do we do this? Okay, pretty easy. So we have to use, it says use variable shadowing when unwrapping. So we have to unwrap it. So when we unwrap things, we're going to use if let greeting equal greeting, and greeting here is we're referring to this string right here, and actually it tells you this with the L string optional. So if greeting equals greeting, then print, what is it asking us to print here? It's asking us to print the actual greeting. Well, greeting, and greeting successful, print hi greeting, and the name as well, I guess. So we're gonna print name. Else, we're gonna print what does it say? Hello and the given name. Okay, hello, and let's go with name here. All right, so pretty much follow the instructions here. And then it says call the function twice. So I'm going to go ahead and call the function twice. And the function is called greeting. So greeting, there we go. And for greeting, we're going to say, it told us to say hi there. And we're just going to say Sarah because that's what they told us to give the name as. And if we go ahead and print this, play this, cannot value of type string string. Cannot call value of non-function type string. Interesting. Okay, so the problem is obviously I try to call the function inside the function recursively. You do not want to do that. You want to call the function out here. And let's go ahead and call this function, and it works. It says, hi there, Sarah. So we called it the first time, and we're going to call it the second time because it said call it twice. So greeting, this time I'm going to pass nil, and I'm going to pass a name here. Whoop, I'm going to say for the sake of logic. And if we go ahead and do this, it doesn't actually run because it doesn't unwrap this. So since this didn't unwrap, it didn't greet with the hi there greeting. Instead, it greeted with the hello for the sake of logic. That's what happened, right? So the else executed. So here we used variable shadowing, right? So we used the same variable name as what was passed through here. Cool. Let's look at the next last bit, I guess. Create a class called car. It should have properties for make, model, and year that are type string, string, and int, respectively. Since this is a class, you'll need to write your own Memorise Initializer. Use shadowing when naming parameters in your initializer. All right, let's do this. Not too hard. Class, right? We use the keyword class, and we're calling it car. Okay, and what are we doing here? We're creating a make. Let make be of type string. Let model be of type string, and let year be of type, I guess, int, they said. Okay, and then we have to create our Memorise Initializer here. Of course, car has no initializers. Okay, that error will go away in a second when we initialize it. So initialize it. Parameters, we're going to go make, and it's going to take a string. We're going to say model. It's going to take a string, and we're going to say year, and that's going to take an int. Beautiful. And in here, we're going to say self dot make equals make, and self dot model equals model, and self dot year equals year. And that's pretty much it. So if we go ahead and run this, there we go. That error goes away, and we're all good here. Fantastic. Let's move on to the next page. All right, page 2. Below is a user struct and 3 user instances. These will be used throughout the exercise below to simulate competition in the fitness tracking app. Okay. All right, great. Okay, the function below takes an array of user. I guess we'll use the stuff above in a second. The function below takes an array of user objects. Okay, that makes sense. And returns the user object that has taken the most steps. Okay, we see that right here. The body of the function first declares a variable that is an optional user. Got it, right here. Then loops through all the users in the array. Inside each iteration of the loop, it will check if top competitor has a value or not by unwrapping it. If top competitor doesn't have a value, then the current user in the iteration is assumed to have the highest score and is assigned to top competitor. Makes sense. If top competitor has a value, there's a code to check whether the current user in the iteration has taken more steps than the user that is assigned to top competitor. At that point, the goal is to assign the user with a higher score to top competitor. However, the code generates a compiler error because due to improper variable shadowing, top competitor has a narrower scope than it should if it is going to be reassigned. Fix the compiler error below and call getWinner competitors, passing in the array. Print the name property of the returned user object. You'll know that you fixed the function properly if the user returns is active user. So top competitor, here's our problem. Top competitor is up here. Top competitor is here. Okay, so the problem is this. We're trying to use top competitor. It's actually not a problem here, but it is a problem here because when we do this if let, we're trying to use top competitor. We're trying to use top competitor in here. That's the problem. We're trying to use top competitor here, but that's in a scope, in a if local scope, where this thing has a function scope. So I guess what did it say here? Change it to, what is it called? Current user. Top competitor, current user. Okay, so all we have to do actually is just change the name of this to, let's say, current user, and we'll have to change this to current user as well. That should fix it. There we go. That did fix it. Fantastic. And then what else did it say? Fix the compile error below. Call get winner. Okay, let's go ahead and do this. So let's make a new instance here. Let some winner equals get winner right there. And for user, we're gonna say competitors. And call get winner, passing in the array. We did that. Print the name property of the returned user object. You'll know that the fix function property of the user. Okay, cool. So now I guess we have to print it. So print winner. I'm gonna go some winner optional dot name optional. Cool. Cannot use optional chaining on non-optional value of string. That should fix it. No, it doesn't. There we go. Cool. So we called some winner, and we got the name of some winner, which is active sitter, which I guess is up here somewhere. That was the winner. Okay, cool. Which makes sense. Most steps today. Active sitter has won, I guess. More than Stepmaster and Monster Walker. All right, interesting. Cool. Let's move on here. Write a Memorise initializer inside the user struct above that uses variable shadowing for naming the parameters of the initializer. Okay, so let's read that again. Write a Memorise initializer inside the user struct above that uses variable shadowing for naming the parameters of the initializer. Okay, so what they want us to do is they want us to create a Memorise initializer here, which shouldn't be too hard. Let's go ahead and do that. Okay, so this is our struct here. That's the struct beginning and end. So we need to make some space here, and we're gonna initialize it. So we're gonna use a variable shadowing. So name is of type string, and steps today, steps today is of type int, right? So identical naming here, right? So variable shadowing, identical. And what we're gonna say is self.name equals name. Pretty easy. And self.steps today equals steps today. So what we're doing is we're taking whoever initializes this thing, we're taking whatever string they give for name, which is right here, and we're putting it in name, which is this. We're taking whatever someone initializes it with steps today here, and we're giving it to the steps today here. And that's pretty much it. Okay, cool. So right, remember we did that. Okay, now write a failable initializer inside the user struct above that takes parameters name and step today as an optional string and int, respectively. The initializer should return nil if either of the parameters are nil. Use variable shadowing when unwrapping. So we're gonna create a variable initializer, and they're gonna be optional string and int. Okay, that's not too hard. Let's go up here. So we're gonna create another initializer, a failable initializer. So we put the question mark here because it's a failable initializer name, and it's of type string optional. And we're gonna go steps today of type int optional. And let's go ahead and start writing this failable initializer. We're going to use guard let to option unwrap. We could use if let, but for this case, guard let is better. Go ahead and watch my guard let lab to understand this better. But guard let name equals name. So this is assuming that you know how to use guard let. The guard chapter is actually quite short and easy. Let steps today equals steps today, else return null. Okay, and now what we're gonna do is we're gonna initialize it, assuming the guard fails. Name equals name and self dot steps today equals steps today. All right, that's essentially it. So essentially we're guarding through here. We're saying guard, so we're optional chaining name and steps today. We're seeing if there's values inside of them or not. If there's no values, we're returning null. If there are values, then we're saying take the values and put them in here. So take the value of this and take the value of this, which is right. So this name represents this name, steps today represents this, and place them in name and steps today, which is this and this. And that's pretty much it. I guess we're done. All right. Thank you for watching. Have a great day.